Good evening, students. I hope you are all doing fine. So, if you know, we will continue with indefinite integration. Last time, if you know, we stopped at this. What is this? In the standard trigonometric substitution, right? So now we'll continue with it. Let's start today's session. So here, we also did this in differentiation, right? Like this is also useful in differentiation. So in differentiation, what do I mean? That uh, if we see something like this format, the first one, second one, or the third one, then it is easier to solve these formats by using trigonometric substitution. Got it? So if we use trigonometric substitution here, like basically we use the properties of identities. So let's check it here. If the format is a square minus x square, the under root doesn't matter. It can be under root, it cannot be under root. So if the format is a square minus x square, then we put x equal to a sine theta. We generally avoid the second cases because no ways you can use anything. There is no reason. Just we use the first one. So let's say suppose I put x equal to a sine theta. Then what will this become? This will become under root of a square minus a square sine square theta. If I take a square common, I will get a square into 1 minus sine square theta. And what is 1 minus sine square theta? It is cos square theta. And if we remove under root, we'll get a cos theta. So this way, this complicated bracket gets simplified to this simple form. Basically, under root gets cancelled. So that's why we mainly use the trigonometric substitution. Now let's try one of the example, or let us try to prove one of the formulae. So here, suppose I need to prove this. Like I need, this is a formula, if you know. So we just prove that what is integration of this equals to. So we saw a square minus x square, the first one only. So we'll put x equal to a sine theta. If you know, we then differentiate with respect to x. So then I will get 1 is equals to a is constant sine theta derivative cos theta into d theta by dx. So if I cross multiply, I can write dx as a cos theta d theta. Correct? I can easily write it as a cos theta d. Now, if we substitute these both in the question, so my question will look like integration of 1 upon what was under root of a square minus x square equal to? It was directly equal to a cos theta. So I can write it as a cos theta into, and dx is equals to a cos theta d theta. So a and cos theta gets cancelled. So we are left with very simple integration of 1 d theta. So this got converted into this, if you can see. So if this got converted into this, that means it becomes very simple because of trigonometric substitution. So it is very simple. Integration of 1 is theta plus c. But as you know, we need to resubstitute. So here, from this, I can say that sine theta is equals to x upon a. That means I can write theta is equals to sine inverse of x upon a. Very simple. So that means my final answer will be sine inverse x upon a plus c. Simple. So for this, as we did this, there are more questions like this, and you can do similarly by using the standard trigonometric substitution. Got it? So next, these are all the formulae, some standard integrals. So what can we do here? We just proved, which one we proved? This one. We proved the fourth one, sine inverse of x by a plus c. So similarly, all of these six you can prove by using standard substitution. If you want, you can try it. And if you have any doubts, then you can bring it to me next time. I will be very happy to solve your doubt. But please make sure that you try this at home. So if you all, let's take some 30 seconds. You all must be knowing this formula. So let's take 30 seconds and fatafat will revise the formula. Got it? So I am also revising. You please revise along with. Okay, we'll take 30 seconds. Okay, done. Let's move on to next. Yeah. So these are two questions. So let's say how I can compare these questions. I can write it as C, integration of 1 upon 2x the whole square plus square root of 11 square dx. So if you see, I can compare it with 1 upon x square plus a square, where we have in place of x 2x and in place of a under root of 11. So what will be my answer? My answer will be very simple. 1 by a under root of 11. It is the first formula, this one. So 1 by a tan inverse of x by a. 1 by a tan inverse of x. Who is x? 2x by a under root of 11 plus c. Now don't forget this 2. Why? Because as we have learned in special case that if in place of x we have linear term, then we have to divide by that. So don't forget this. Correct? Now you can try this one and you can tell me the answer. So if we try this one, I will get it is of the form 1 upon under root of 11 square minus 2x the whole square dx. So this is of the form. If you tell me, I can see it out. You can also see it 1 upon under root of a square minus x square, the one we just derived. So in place of a, we have under root of 11, and in place of x, we have 2x. So again, what will be my answer? 1 upon under root of a square plus x square, sine inverse of x by a plus c. So I will get sine inverse of x by a plus c, but don't forget 1 upon 2. Why 1 upon 2? Because it is coefficient of x. Because it is coefficient of x. Got it? So these are simple examples for those formulae. Now let us take some more interesting examples. Suppose this one. So you know how this looks like? According to me, it looks like 1 upon under root of x square plus a square, where in place of x we have 2 minus x and in place of a we have 1. So if you remember the formula, 1 upon under root of x square plus a square, this one, log of x plus under root of x square plus a square. right? This will be equal to log of x, which is 2 minus x, plus under root of x squared, 2 minus x, the whole square, plus 1 square, plus c. So if I try to simplify this, like if I try to open this bracket, what will I get? I will get log mod 2 minus x plus under root of 2 square, which is 4, and 4 plus 1 will be 5. X square minus 4x plus 5 plus c. This is my answer. This is very simple example. What does this look like of the formula? It looks like 1 upon x square plus a square, where in place of x, so we have x, and in place of a, we have 2. In place of a, we have 2. So that means this is first formula, 1 upon a, 1 by a, tan inverse x by a plus c. Simple. If you can remember, like these are very good questions. Just warm up type questions, you can say. That means that you can just know how to apply the formula. Got it? Here. Now these are very good questions. What we can do here, see. Here we have to do one more step before directly applying the formula. So as you can see here, if I put tan x equals to t, like if this is f of x, and this is my f dash of x. So that means if I put tan x is equals to t, then sec square x dx will be equal to dt after differentiating. So my integral will become sec square x dx will become dt, and I will get 1 upon under root of t square plus 4. Now, how does this look like? This looks like 1 upon under root of x square plus a square. Got it? In place of x, we have t, and in place of a, we have 2. So simple. So that means, do you remember the formula for this? 1 upon x square plus a square, this one. Log of x plus under root of x square plus a square. That means log of t plus under root of t square plus 4 plus c. Now last step, what we'll do? We'll resubstitute. So if I resubstitute, that means in place of t, I will write tan x. So half mod of tan x plus under root of tan square x, right? Plus 4 plus c. This is my answer. Here, this is also similar case. Now, see x square we have, right? So I'll suppose say x square dx. Na? This is x square dx. So suppose if I put x cube equals to t, that means I will get 3x squared dx. 3x square. Okay, where is it? 3x squared dx is equals to dt. So if x cube equal to t, that means if I square on both sides, x raised to 6 will be equal to t square. Correct? So I will get integration of dt 1 upon t square plus 1. Now how does this look like? This look like 1 upon x square plus a square, where in place of x we have t and in place of a we have 1. So that means I can write it as, what was the formula? 1 by a tan inverse of x by a plus c. So a की जगह पे 1 है, so it doesn't matter that much. So that means my final answer after resubstituting will be tan inverse of, in place of t we have x cube. So tan inverse of x cube plus c. This is my answer. Simple. I hope you are getting it. So these were some of the examples which we can do. Got it? For those formulae. Now, let's move on to the next part. If these formulae were clear, let's move on to the next part. Next was the interesting part. You must have done this before also, but we'll again revise it. Not the method, the technique you must have done before, which is completing square method. Now, what do you mean by completing square method? You must know this. To make a perfect square out of a quadratic. If a quadratic equation is given to me, how do I make it a perfect square? So I basically use these 3 steps. I hope this will be useful for you too. So first is, make the leading coefficient equal to 1. Leading coefficient means coefficient of the square term in quadratic. Then we do add subtract half into coefficient of x the whole square. And then we make the perfect square with the added number. So let's try example here. If I do step 1 here, what is step 1? Step 1 is take 3 common. If I take 3 common, that means my leading coefficient will become 1. So I will get x square plus 4x plus 9, I suppose. Yes. Now, what is step 2? Step 2 is add and subtract half into coefficient of x, the whole square. Meaning, I have to add and subtract 2 square. That means I have to add and subtract 4. So therefore, if I add and subtract 4, my quadratic will become x square plus 4x. I will add 4, I will subtract 4, and this is plus 9 as it is. So now you can see these 3 terms will make a perfect square according to step number 3. These 3 terms will make a perfect square. And you can see what is the perfect square. It is x plus 2, the whole square. This is step number 3. 9 minus 4 is 5. So we'll get plus 5. So in this way, I can write this equation in the form of this by using completing square method. Now let us see how this method is useful for us in integration. Got it? So let's say, suppose I take an example, this one. So here the quadratic given is 7 minus 6x minus x square. So if I rearrange, I will get minus x square minus 6x plus 7. Got it? So what was step 1? Step 1 was take minus 1 common. So I'll get x square plus 6x minus 7. Now what was step 2? Step 2 was add, subtract half into coefficient of x, the whole square. That means add and subtract 3 square. That means add and subtract 9. So what will I get? I will get minus 1. Or suppose let's write minus only. No need to write 1. I will get x square plus 6x plus 9. Minus 9 and minus 7, it was already there. And now step 3 these terms will make a perfect square. Can you guess which perfect square it is? It is minus, this is step number 3. X plus 3, the whole square, and minus 60. So if I put the minus inside, I will get 16 minus minus plus, and 16 ko I can write 4 square minus x plus 3 the whole square. So now my integral will become integration of 1 upon under root of 4 square minus x plus 3 the whole square dx. Got it? So if you can remember, what is this form? Fatafat. This is of the form 1 upon under root of a square minus x square, the one we derived, where in place of x we have x plus 3, and in place of a we have 4. Got it? So that means I can now use the formula. Do you remember the formula? It was sine inverse of x by a, right? So I will get sine inverse of x by a. That means x plus 3 upon 4 plus c. This is my answer. So simple. Got it? I hope you are getting it. Right? So if this is very clear, let's move on to the next. These completing square is used. Let me tell you here, fatafat. Yeah, completing square is used for the integral of the form when we get 1 upon quadratic. Integration of 1 upon quadratic dx, or integration of 1 upon root quadratic dx. So if out of these two we get, so this example was 1 upon root quadratic type. Correct? It was 1 upon root quadratic type. Got it? So yeah, let's move on to the next part. Next is, now if we 1 upon quadratic is done, so if what we get linear upon quadratic, got it? Linear upon quadratic. That means it is of the form this. So what do we do? Same, we do the same steps. Like we put px plus q. That means I will write it as, let me write it as, how do I say it? Linear is equals to a into derivative of quadratic plus b. If I write it this way, and then I will compare these equations, or you can say solve these equations to get value of a and b. This is very important. This is my mantra. You understand mantra? Mantra means like I have to use this if this format comes. Linear upon quadratic, or this one, linear upon root quadratic. So what is my mantra? Linear equals to a into derivative of quadratic plus b. A into derivative of quadratic plus b. So if you are clear with this, let's try an actual example. What will look like? Got it? This one. So this is of the form linear upon quadratic. So what was the mantra, or you can say Brahmastra? It was linear is equals to a into derivative of quadratic. You can say the derivative will be 2x minus 2 plus b. If you are getting it, then we'll solve these equations. How will we solve this? We'll compare directly. So if I write it as 2ax plus b minus 2a, and here I will get x plus 3. So comparing x ka coefficient. If I compare x ka coefficient, I will get 1 is equals to 2a. That means a is equals to 1 upon 2. And if I compare this, I will get 3 is equals to b minus 2a. And 2a was 1. So 3 is equals to b minus 1. So b equals to 4. So that means I can substitute these both here. So I will get x plus 3. I can write x plus 3 as half into 2x minus 2 plus 4. So now my integral will look like integration of half into 2x minus 2 plus 4 upon x square minus 2x minus 5 dx. Now please come bear with me. After this is a very important step. We split the numerator. So that means I will get integration of 1 by 2 into 2x minus 2 upon x square minus 2x minus 2, right? Plus 4 upon x square minus 2x minus 5 dx. So if I use the rule number 2, I will get half bar integration of 2x minus 2 upon x square minus 2x minus 2 dx plus 4 is constant bar integration of 1 upon x square minus 2x minus 5 dx. Now if you remember, this part is 1 upon quadratic, and 1 upon quadratic part means we use completing square method. So if you use you'll use completing square method. I'm giving you to try it at home. So if you try it at home, you can cross check it or verify it with me in the next class. And here this is important. So this is basically f of x, and this is f dash of x. So I'll solve this for you. I will get 1 upon 2 integration of 1 upon t dt. Correct? Because we put f of x equal to t. So we put f of x equal to t, and this will be dt. Correct? So I will get this one. So I will basically get 1 upon 2, 1 upon t ka integration log of t. But I will not write t because we have to resubstitute t. Who was t? F of x, which is x square minus 2x minus 2 plus 4 times whatever here comes plus c. So whatever here comes, I am giving you for homework. Got it? We have practiced some questions on 1 upon quadratic. You can try it at home. Let's do one more question of this type. This one. This looks like linear upon root quadratic. So it doesn't matter what it looks like. We'll have to do the same thing. So we'll write linear is equals to, do you remember this? Linear is equals to a into derivative of quadratic plus b. So linear is equals to okay. Here we had 2. Yeah. So linear is equals to a into derivative of quadratic. It is 2x plus 2 plus b. So if I open the bracket, I will get 2ax, correct? Plus 2a plus B. So let's compare here. So that means 1 is equals to 2a, and that means a equals to 1 upon 2. And if we compare here, 2 is equals to 2a plus b. That means 2 is equals to 2a का value क्या था? 1 plus b. That means I got b as 1. If we substitute both of them here, what will I get? I will get x plus a into 2x plus 2 plus 1, right? So now my integral will become integration of 1 upon 2 x, oh sorry, 1 upon 2, 2x plus 2, right? 2x plus 2 plus 1 upon under root of x square plus 2x plus 3 dx. Correct? So now if I split the integral as we did in the last question, I will get 1 upon 2. I am skipping one step. Please don't mind. So I'll get 1 upon 2 integration of 2x plus 2 upon under root of x square plus 2x plus 3 dx, correct? Plus integration of 1 upon under root of x square plus 2x plus 3 dx. Now, what is this? If you remember, this is the completing square method. That is 1 upon under root of quadratic. 1 upon under root of quadratic. You can do this again at home. Here, please see, if I take it as f of x, so this becomes my f dash of x. And we put f of x equals to t. Correct? So that means I will get 1 upon 2 integration of 1 upon root t dt. So what is integration of 1 upon root t? It is, I guess, 2 root t. It is 2 root t. So 1 upon 2 into 2 root t. And 2 cancel. And what is in place of t? In place of t we have this. So that is basically under root of x square plus 2x plus 3 plus whatever here comes plus c. This is my answer. I hope you are clear about this. So these are the two questions that we have done of linear upon quadratic and linear upon root quadratic. There is no need, like, there is no need to do more questions, I guess. If you require, if you, then I will surely do next time. Or you can, best ways you can bring doubts. Like I have explained the method. You can again go through these questions and see the method or see the step. This is basically a one-time investment, I would like to say. One-time investment means if you learn it one time, then it is like you don't need to do again and again until the day of exam. Correct? Now, after this is over, we are going to start with next important part, which is partial fractions. Partial fraction. Now, what do you mean by partial fractions? Let me just introduce you. Suppose these are two polynomials, fx and gx, and we take their ratio. Then this is a rational function. Now, rational functions are of two types, proper rational and improper rational. Correct? So, what are improper and proper rational? So, it is a proper rational function if degree of f of x is less than degree of g of x. It is a proper rational function if degree of f of x is less than degree of g of x. This is called proper rational function. And we use partial fractions for proper rational functions. Means polynomial upon polynomial where numerator ka degree is less than डिनोमिनेटर काटेंगे. So this is called as proper. Got it? So these proper rational functions are basically of three types. What are those three types? So the first is denominator is expressed as non-repeated linear factors. Means there are linear factors, but they are not repeated. Repeated linear factors. Repeated linear factors means perfect square. Like if x minus 2 is repeated 2 times, that means x minus 2 into x minus 2 whole square. If x minus 2 is repeated 3 times, x minus 2, x minus 2, x minus 2, that is x minus 2 the whole cube. So these are repeated linear factors. And third, product of linear and non-repeated quadratic. Means we have a linear and बाजू में quadratic. Got it? So first one is linear. Second one is linear, but they can be repeated. And third is linear into quadratic. Okay? So how this looks like? Here. This is what I was talking about. The first, second, and third. This is my rational form. Got it? Here x minus is repeated 2 times because it is square. This is my rational form. So I can write this rational form in partial forms. Now what do you mean by partial forms? These are the partial forms. Like for one, the corresponding partial form is a upon x minus a plus b upon x minus b plus c upon x minus. For two, the corresponding partial form is this. And for the third one, the corresponding partial form is this. Now, how do I remember? If the factor is linear, then we only need a constant here. But if the factor is quadratic, then we need a linear term here. We need a linear term here if the factor is quadratic. Got it? So obviously, you don't need to ratta this. Ratta means like you just need to practice it enough times. This is x minus c. Sorry, this is x minus b. Yeah, here x minus b it is. Huh? So let's try one example, and it will be clear. Got it? Now this ABC, if you remember from these questions, this ABC, we found the value of A and B, right? We found the value of A and B. Similarly, here also we need to find the value of these A and B, or sometimes C also. Got it? Now, we'll do example for each of the three rational forms. Let's look at it. The first rational form. This is the first rational form. Got it? So that means I can write this rational form 3x minus 1 upon x minus 3 into x minus 2 as linear form or partial form as a upon x minus 3 plus b upon x minus 2. Now on the RHS, if we take LCM, I will get a into x minus 2 plus b into x minus 3. And if denominator में जो भी आएगा, that will get cancelled because the denominator is same on the left hand side. So that means I get an equation 3x minus 1 as this. Now, to find a, what I'll do for capital A, if I put x equals to 3, let's put x equals to 3. That means this term will get cancelled. Why? Because this will get 3 minus 3, which is 0. Right? So I will get 3 on the left hand side. I will get, 3 into 3 minus 1 is equals to a into 3 minus 2. 3 minus 2 is 1. That means a ka value is 309 minus 1, 8. And similarly, can you tell me for B? For B, what will I put x as? 2. Superb. X equals to 2. This will get cancelled. I hope you are getting it. So that means I will get 3 into 2 minus 1 plus, sorry, plus nahi, equals to B into 2 minus 3. So I guess I will get B as 3 to the 6 minus 1, 5 minus 5. Now substitute both of these values here. Both of these values here. So if I substitute both of them here, I will get 3x minus 1 upon x minus 3 into x minus 2 can be written as 8 upon x minus 3 minus 5 upon x minus 2. Now I wanted integration of dx. That means this is integration of dx. Now by the second property, I can write it as integration of 8 to constant bar, integration of 1 upon x minus 3 dx minus 5 bar integration of 1 upon x minus 2 dx. And what is the integration of 1 upon x? It is log mod x minus 3 minus 5 into log mod x minus 2 plus c. This is my answer. Got it? So by using partial fractions, my integral, like this was non-integrable. So by using partial fraction, I have converted into an integrable format. What is integrable format? Integral format means which I can integrate. Simple. So let's try the second one now. This is the second type. Repeated linear. Do you remember the partial form for repeated linear? The second one, it is a upon x minus a, b upon x minus a, the whole square, plus c upon x minus b. Let's try this. So I can write 3x minus 2 upon x plus 1, the whole square, into x plus 3 as a upon x plus 1 plus b upon x plus 1 the whole square plus c upon x plus 3. If you remember this form, got it? So now again we'll take LCM. Again, after taking LCM, both the denominators will get cancelled. So can you tell me the LCM? LCM will be, I suppose, the left hand side में तो denominator cancel, so I'll get 3x minus 2 is equals to a into, I'll get x plus 1 into x plus 3. Correct na? Plus b into x plus 3 plus c into x plus 1 ka whole square. Now again, we have to do this 3 times. That is for A, then for B, and then for C. So for A तो अभी के लिए stop करना पड़ेगा. We'll do first for B. So for B, if I put x equals to minus 1, got it? So minus 1, so this will get cancelled, this will get cancelled. करेक्ट ना? माइनस 1 प्लस 1 0 हो जाएगा, ये भी क्या हो जाएगा 0. तो आई विल गेट 3 into minus 1 minus 2 is equals to b into minus 1 plus means minus 5 ना? Is it minus 5 correct? Minus 3 minus 2 minus 5 and this is 2. So this is basically minus 5 by 2. Now for C के लिए तो सिंपल है, x की जगह पे क्या रख दो minus 3. So this will get 0, this will get 0, correct? So I will get 3 into minus 3 minus 2 is equals to c into minus 3 plus 1 the whole square. So I guess C will be minus 9 minus 11, correct? So minus 11 upon 4. Now for A, I can select any number. I can select any number. So for A, what to do? Let's come here. So for A, I'll put x equals to 0. X equals to 0. So on the left hand side, I will get 3 into 0 minus 2 is equals to A. Here it will be 1 into 3 plus. Correct, na? Am I making a mistake? No. 1 into 3 plus. B into 3 plus C into 1. And we know the value of B and C. Substitute the value of B and C. So what will I get? Yeah. I will get minus 2 is equals to 3A. Correct? Plus 3B, which is 5 by 2. Plus C is minus 11 by 4. That means minus 2 is equals to 3A minus 15 by 2 minus 11 by 4. So minus 2 is equals to 3A. This is multiplied by 30. 30, 11, 41. That is minus 41 by 4. That means 3A is equals to 41 by 4 minus 2, which is equal to 4 to the 8. If I take LCM, then I'll get 33, I guess. 33 by 4. That means A is equals to 3 and 33 will get cancelled. 11 by 4. So I got A equals to 11 by 4. So now if I substitute all these values, the value of B, C and A here in this equation, what will I get? Okay, let's use a new slide. Yeah, so what will I get? 3x minus 2, 3x minus 2 upon x plus 1, the whole square, into x plus 3 will be equal to A 11 by 4 upon x plus 1. Then B, right? B was minus 5 by 2. So plus minus 5 by 2 upon x plus 1 the whole square plus, and C was minus 11 by 4. Minus 11 by 4 upon x plus 3. That means if I integrate this, that means I integrate this with respect to dx. So that means we are very close to the end of the question. What will I get? I can write it as 11 upon 4 integration of 1 upon x plus 1 dx minus 5 upon 2 constant integration of 1 upon x plus 1 the whole square dx minus 11 upon 4 integration of 1 upon x plus 3 dx, and 1 upon x का integration is log mod. So I can write it as 11 upon 4 log mod x plus 5 by 2. Could you remember this integration? It is minus 1 by x. So minus minus plus 1 by x plus 1. And lastly, minus 11 by 4, same log mod of x plus 3 plus c. If I take these two terms, the first and the last one, so I'll get 11 upon 4 common, and I will get log of x plus 1 minus log of x plus 3 plus 5 upon, if I multiply it, I'll get plus 1 plus c. So 11 upon 4 into log mod x plus 1 upon x plus 3 plus 5 upon 2 into x plus 1 plus c. This is my answer. I hope you got it. So this was a very good question. I enjoyed solving. It was a bit lengthy, but yeah, if we again, we can definitely get some speed. So this I did every step because I was doing it for the first time for you. Usually I don't do this all these steps. I just skip. I can calculate in my mind and directly I'll write the answer. So this looks lengthy, but if you practice it enough time, then it will not look lengthy. Like you will do it like this. Comes. I guess we should stop before starting next chapter. Sorry, next topic. Before starting next topic. So I guess we'll continue it next time. We are left with this third one. So I guess if we start the third one, we'll not be able to complete it in time. The third one, the third one, right? Where we have quadratic. Got it? So yeah, let's just revise it what we did today, and we'll then end the session. So I just like do the slides. I'll shift the slides. You just pay attention, and if you want me to stop at a particular slide, you can surely tell me. Got it? So let's just fully concentrate on the screen and go through what we did today. It's basically a recap. I will be talking on the background, so also please keep listening. So here, first we did the standard, right? There are three standard trigonometric substitution: a square minus x square, a square plus x square, and x square minus a square. So we did one proof of the formula, and after that, we look at this six formulae. These six formulae are, again, you can do the same way we did this one, right? Just standard substitute and it will become very simple and you will get your answer. So these formulae we need to learn. After this, we did some questions. Like these were some warm-up questions. You can say warm-up questions if you understand, just to get the gist of how to use the formula. Correct? So these four questions I did, I suppose, this first, two, third, and fourth. Correct. Did four questions. No problem. These were simply questions. And then after this, we did this. The next. Where we used substitution and then use those formulae. We use substitution and then use this formula, correct? In both the questions. So yeah, we sometimes or need to use substitution to make the format integrable. After this, we use this very important method, which is completing square. Completing square is a very good method. You must have done it in the quadratic equations chapter. After this, we did some question like how to use completing square here. After this, we saw integral of the form this, linear upon quadratic. What was our mantra? This, linear equals to a into derivative of quadratic plus b. A into derivative of quadratic plus b. Got it? After that, we solved these questions here. For this homework, I hope you don't forget it. You can note down this and you can try it yourself. Also, this one we did, the under root one. And finally, we did the most important thing, partial fraction. Now, I told you, partial fraction may we have two. Rational fraction may we have two. Proper rational, improper rational. We here saw a proper rational function. What is proper rational function? When degree of numerator is less than degree of denominator. Got it? So next time we'll also see what is improper rational function. Obviously, you must have guessed it. Improper will be greater than. less than का opposite, na? It is greater than. So in here we have three types of rational forms: non-repeated, repeated, and linear into quadratic. So of these, we did two questions of first and second. Second was one a bit lengthy. Now third one will be more lengthy. But I hope you are ready. Not lengthy. If you enjoy it, then I don't think it will be lengthy. Got it? So here we did the two examples, the first one and the second. After using partial fraction, main headache is not integrating. Main headache is this. See, if you can see, integration is only these two steps, right? Only these two steps. The integrable form is very simple. Just we need to find A and B. That is a task. And that is not like, it is basic calculations of school level. So here we did A, B, and C. And then integrable, if you see that in only these two steps are of integration. Correct? We just integrate it. Okay, got it. So thank you all. We'll end the session here. I hope you understood it. We'll meet next time. Next time is today's Friday. So next we'll meet on Monday. I hope you enjoyed the lecture. Thank you all. Bye bye. Take care.